Hello everyone, welcome to the third lecture of this lecture series. Today we will be dealing with the various case studies that come across our numerical problems or that we study in mechanics. Okay, so let us move to the very first one. First one is when the object is kept on a flat surface. Object is kept on a flat surface. Now flat surface could be anything, a table, a ground or something. Let me consider this surface which is flat and I have a box which is lying above this surface, right? So what will be the forces that will be acting on it? There will be two forces. First one will be the normal reaction force. You already know it, and the second one would be your gravitational force. Okay, this one is mg and this one is the normal reaction. So if I consider this, that the motion is restricted, means the box is not moving in any direction. I have also considered this as y and this as x direction. If the motion is restricted, then what would happen is that you already know force in x direction is equals to 0, while the force in y direction, though it is also 0, but how can we write it? The force in F in y direction would be mg minus n, that would be equal to 0, or simply we can say mg is equals to n. Okay, so this is the all thing that you do when you see a box lying on a flat surface or an object lying on a flat surface. There are only two forces acting, that is the normal reaction force and the second one is the gravitational force. Okay, given that the motion is restricted. Now let us move to our case number 2. We have our case number 2, which is in a lift which is moving downwards. Object in a lift which is moving downwards. Object in a lift moving downwards. Okay, moving downwards. So let us consider a lift. This is a lift and we have again an object which is kept on the lift. Now what will be the direction of the forces that will act on this object? Let me draw them for you. First one is again the normal reaction force, then we have this mg, and the whole system is going downwards with the acceleration. Okay, now according to the axes that we have put, so I will, in every problem I will put my axis as this only, y and x. If I'll change, I'll let you know. So okay, so if I forget to write this, don't mind and consider this as the only axis. Now there is no motion along the x-axis, you can see, so we will only resolve along the vertical axis. Okay, the vertical axis or the y-axis. So from the Newton's law, F is equals to mass into acceleration, right? So what is the F, or I must say F net force acting is equals to mass into acceleration. So what is the F net acting? That is equals to mg minus n is equals to m times a, or we can say n is equals to mg minus ma, or simply n is equals to mg minus a. Okay, then the normal reaction acting on the body is Ng minus A in this case, Mg minus A. Also, similar thing, can you tell me now what will happen if the lift is going upwards? If the lift is going upward. What will happen to n? You can simply write m is equals to g plus a. Then the acceleration will be in upward direction, and we will be writing mg plus a here. Okay, moving to our next case, which is very common again, case number 3, that is inclined plane problem, right? Inclined plane problem. Everybody has seen a various number of inclined plane problem. Now I have also discussed a bit of it in the previous lecture, I remember, but I'll discuss it again. So how does an inclined plane problem goes is like we have an inclined plane, which is at a certain angle theta, and we have some kind of box which is sliding down the inclined plane. In this also I'm considering this as y and this as x-axis. Now there is a downward force which will be acting on the body, right? Oh, let me take it from the center. Backward of this, right? And if this is theta, we all know this would also be theta, and there would be another component of this mg that will be along this direction, and one other component of the mg that is in this direction, right? These would be all the forces, and also if you would not have forgotten, there is a friction force that will act on the body in the very opposite direction of it. Friction force. So if I name all these forces, this is our mg. This, what would it be if, I hope you know the resolving of the forces very properly. This would be our mg sine theta. This is our normal, and this is mg cos theta, right? So along x direction or along the y direction, we would say, let us see along x direction, right? Or there is one more thing, we won't consider this as xy. Our xy would be like this along the plane. Okay, this is my y and this is my x. Along x direction, what all forces do we have? Mg sine theta minus F, our friction force, that would be equals to mass times acceleration. I can also write this as again F net is equals to ma. Okay, and along y direction, what all forces do we have? We don't have net acceleration or movement of the body in y direction. We can again write F net is equals to mass times acceleration. What is the net force? That is mg cos theta minus n, that is equals to 0, or mg cos theta is equals to n. Okay, now what can I do is, these are the our equation 1 and equation number 2 are the standard equations that will help us to solve the various numerical problems if that given the conditions. According to the given conditions, these two are the one. And also, if I consider the case when no friction is there, in case of no friction, in case of no friction, we would have mg sine theta from equation number 1 minus 0 is equals to mass times acceleration, or mg sine theta is equals to ma and g sine theta is equals to a. So in the absence of friction, the acceleration on the body would be equals to g sine theta on an inclined plane. Now let us move to our case number 4, which is object hanging, right? Hanging objects. Case number 4, that is our hanging objects from an inextensible string, right? So this is a roof or something, and what do I do is I hang an object from here. This is my object, or let me also draw this one. This is my object hanging from a ceiling or something. So what will be the forces that will be acting on this? First one would be the uh, force due to gravitation, here mg, and the other one would be the tension. Okay, mg and tension. What is tension, if I may ask? What is tension? So tension is the contact force that acts along the length of the string. Okay, when we have something placed on a surface, we have a normal force that acts in the upward direction. Similarly, we have a tension, which is a contact force, that acts on a that acts on a or I may say that acts along the length, that acts along the length of the string on which the mass hangs, right? So we do not have any acceleration or movement or forces around the x direction. We only have to resolve around y. So along y axis, what all forces do have? F net is equals to ma. Then we have t minus mg is equals to 0, and t is equals to mg. Okay. Then there is the pulley mass system. Okay. Pulley mass. Pulley mass system, or we also call it Atwood machine. Okay, we have again a surface and a pulley. That is kept here. This is my M1, this is my M2. What do we have here? T1 and T2. let us say it rotates in this direction with an acceleration of a. So what do I do is, rather than using my mind, I would simply see the forces acting on the body separately. This is the m1g force and the tension is T1, and then we have the second body M2 which has the T2 force, and the force is gravitational force is M2G. Okay, then along M1, if I see, this is for, let us say, M1 and this is for M2. Along M1 I will see F net is equals to mass times acceleration. We have T1 minus M1G is equals to mass times acceleration, or I can say T1 minus M1G is equals to mass time M1 M1 into acceleration, and let us come to T2. Similarly, F net is equals to mass times acceleration, and M2G minus T2 is equals to mass times acceleration M2 into A. Here I wrote M2 minus G because the acceleration of the body is downwards while the acceleration in M1 was upwards. Okay, now if I add both of my equation 1 and equation 2, adding 1 and 2, what do I get? T1 minus M1G plus M2G minus T2 is equals to M1A plus M2A. Okay, this is a system of massless pulley, and the speciality of massless pulley is that T1 is equals to T2. Okay, if T1 is equals to T2, this will cancel out this and we would have M2G minus M1G is equals to M1 plus M2 into A. So we can write it as M2 minus M1 into G upon M1 plus M2 is equals to A. So this is the acceleration which arises when we solve a massless pulley system. Okay, the acceleration which arises due to the massless pulley system, m2 minus m1 into g upon m1 plus m2. This is the net acceleration. Now there is also one another thing. This was the massless pulley, or let us do that in another session, I would say. Or let me just do it right now. We have, this was number 5, and then we have number 6. Also, let me remind you one thing. There is the case of massive pulley in which the T1 is not equals to T2. Okay, we have similar kind of thing, like this is the pulley and here is, let us suppose there is T1 and let us suppose there is T2, and this is rotating by some alpha and we have this R. So here we write tau is equals to T2 minus T1 into R. Tau means here the torque. Okay, the torque that is acting on the body, that is T2 minus T1 into R, or we write it as I alpha, that is the moment of inertia into acceleration, angular acceleration. Also when we solve it, we get half m p r square into alpha. What is half m p square? Inertia, this moment of inertia, half m p square. This is mass of pulley into r square, not p square, of mp r square. Okay, I'm not going into detail of this massive pulley. I'll be moving ahead with next thing, that would be friction. How do we deal with the problems with friction? Okay, whenever we have friction, wait, verse 6 is friction. Whenever we deal with the problem of friction, or something is given like this is a surface and we have a box lying above it, so there is always a normal reaction force acting on the body and G acting downwards, and then there is a friction force that acts on the body, right? What is the speciality of friction is it always opposes the motion. Okay, friction always opposes the motion. Hence it always acts in the opposite direction of force, in the opposite direction of force. Okay, if I see what is, how do we write friction is F is equals to mu times N. Now what is mu and what is N? Mu is the coefficient of friction and N as usual is the normal reaction force. What is the cause of basically arising of the friction? Like if I see this surface and this surface here at a point, so it arises due to the cohesive and the adhesive forces of the bodies. You know what are cohesive and adhesive forces? If I zoom here again, if I zoom here, I'll see various. This might look smooth, but it is actually not smooth. Even the smoothest surface is not smooth. It have some grooves and edges. Okay, and this is the box surface, and this is my actual surface. Okay, my actual surface in which I have kept it. So this point will have some adhesive forces, cohesive forces with this. Cohesive forces cohesive are, so this surface will have some attraction or cohesive adhesive forces with this, cohesive and adhesive forces with these points. Okay, then this would be resulting in the friction. What are cohesive forces? Cohesive forces are the one which acts on the same kind of surface, and adhesive means which acts on the different kind of surfaces. Means if this and this surface are same, those are cohesive, and if this surface and this surface is of different material, then the forces between these edges would be the adhesive forces. Okay, I hope you have understood a bit. So F is equals to mu n. Okay, coming back to the topic, and then there are basically friction of two kinds. One is the static friction and other one is the dynamic friction. There are two kinds of friction. One is the adhesive friction, one is the static friction and other one is the dynamic friction. Now static friction is due to the when the body is at rest. Okay, at rest, when the body is kept, we have static friction, and when the body starts moving, we have our dynamic friction. If I plot a curve of it, if I plot a graph for our static and dynamic frictions. Let us say this is my friction and this is my force applied. Okay. So what kind of curve do we get when we plot this? We have a straight line at first, then there is some groove, and then we have a straight line again going up. Or then we have, let me plot again. We have a straight line first, a kind of groove, and then we have a straight line. So this is the point of static friction, and then we have the dynamic friction. Also, there is a kind of thing like, if the friction is less than F is equals to mu n from here, if the friction is less than mu n, the body does not move. And if the friction is greater than or equal to mu n, then the body will start moving. So now I have discussed this friction case already, and I should have discussed it right now with the friction, but it's completely okay. It's the inclined wedge thing. And you can see if we put a wedge and there is a friction, there is only a single force that would be acting backwards, and we have already calculated the acceleration for it. Okay. So moving to the things that we have studied today are, let number one was the case study that we did on the object on a flat surface. So there are only two forces acting on the body. One is the normal reaction force and other is the your gravitational force. Okay. And we considered that the motion is completely restricted here, right? So in the flat surface, what do we see? There are only two forces, that is the normal reaction and the gravitational force, and we considered that the motion is completely restricted. Moving to the case number two, we have the lift moving downwards, and along the vertical we consider the motion, and the horizontal axis is not, in the horizontal axis there is no force. Okay. Then moving to the third problem in the inclined plane problem, we considered the friction in this case, and we had our equations, force equations for both the x-axis and the y-axis. Okay, and then moving to the next case, now you know that there are, in the inclined plane problem we considered theta, and I hope you are aware of the resolving of the problems, and we considered the y-axis and the x-axis according to the surface, and we have considered the friction force already here. And we got the equation number one and equation number two along x direction and the y direction also from the net friction. In case of no friction, we got a is equals to g sin theta. Moving to the hanging object case, we considered the tension. We defined tension, that which was the external force or the contact force thing, and then from there we got T is equals to mg. T is equals to mg, and then there is the pulley mass system or the Atwood machine, in which we consider the massless pulley, and there is one important thing here, that T1 would be equal to T2 only when there is the massless pulley, and we have two equations, f T1 is equals to m1g, and then we got to our acceleration formula from the both the equations, which was m1 minus m2 g upon m1 plus m2. I also briefly discussed the thing of the massive pulley, sorry, and there we use the T2 minus T1 into R formula for the calculation of the torque, and also that can be written as I gamma. Okay, and I have already said T1 is equals to T2, is only when there is the massless pulley. Okay, it won't be there in the case of the massive pulley. And we calculate I alpha. Alpha is nothing but angular acceleration, and I is written as mpr square, which is nothing but the moment of inertia for that. Okay, then we came to the case of the friction. Friction is nothing but a force which always opposes the motion. Okay, and it always acts opposite in the direction of the force applied. We also then calculated the formula or saw the formula, which was F is equals to mu n, and there are two times kinds of friction, which are static and the dynamic. Also the mu here is the your coefficient of friction, and then we saw the curve that we get of the static and the dynamic friction, and the force, if is less than mu n, the body will not move. Sorry, here it would be force, and if the force would be greater than mu n, the body will move. Okay, let me just correct this force and friction thing. Let me write force here. If the force is less than mu n, if the body will not move. Less than or equal to mu n, the body will not move, and if the force is greater than mu n, the body will move. Okay, so this is it for the complete lecture. Thank you for joining. We will meet in the next lecture with some different topic of the mechanics as we go ahead. So this is it for this lecture. Thank you for watching. Bye bye. Take care.